So to back up a little bit to this idea of a Venn diagram that we introduced in a kind of a complex example, what we have here is an example of a Venn diagram. And we're going to be looking at some other Venn diagrams throughout this section to help us understand the relationships among sets and even among elements of sets. Okay. So when we write this notation, A is a subset of B, we're saying that every element of A is also an element of B. So we're working toward a more formal description of the subset idea. So when I write A is a subset of B, I'm saying in words A is a subset of B. I could also write that same thing this way. I could read this as A is a subset of B. So I could write it another way like this. Or I could also say B is a superset of A. Either way is okay. And what we want you to start noticing is that these symbols are very similar in behavior to certain inequality symbols we've used before in our math career. Okay. So let's take a moment to write some subset relationships from the Venn diagram in the previous example, or in the previous video. Okay, let's see. So what do we have? We have, let's see, which sets are contained in which? Well, C is contained in U, so I can write that. C is a subset of U. What else? And P is also a subset of U, so I can write that. And then let's see, R is a subset of P. L is a subset of P. So I could write R is a subset of P. I can write L is a subset of P. Notice too, L isn't just a subset of P, it's actually a subset of my universal set, U. So I could have also written L as a subset of U, and similarly I could write R as a subset of U. What about S? We haven't talked about that yet. S is a subset of R, and it's also a subset of L. S is also a subset of P, and it's a subset of U. So let's write that down. S is a subset of R, S is a subset of L, S is a subset of P, and S is a subset of U. Let's take a quick moment to review what these statements are saying. When I say something like R is a subset of P, because R is a set of rhombuses and P is a set of parallelograms, another way to say this is every rhombus is a parallelogram. Everything in the set of rhombuses belongs in the set of parallelograms. Every rhombus is a parallelogram. We're not saying that the reverse is necessarily true. In this case, it's definitely not true. But that is an example of what these subset statements can be saying. Oops. Some of them stayed together and some of them didn't. That's okay. All right. Some possibly more familiar examples of subsets. We have that the set of natural numbers is a subset of the integers. The set of integers is a subset of the real numbers. And then we could combine these two statements into a statement like this, which is very reminiscent of when we do something like that for inequalities, right? When we say something like x is less than or equal to y and y is equal to z, that's the same as saying x is less than or equal to y, which is less than or equal to z. So more generally, we have that n is a subset of z, which is a subset of q, the rational numbers, which is a subset of r, the real numbers. Okay, so we're still building these connections between the subset symbol and the less than or equal to symbol. Now, what you've been seeing so far is phrases like it is clear and it is obvious. It's not a great thing to say that in a math textbook, but I think what the author's trying to do is to show us different ways of starting sentences, because remember, one of our guidelines for writing math is that you don't start a sentence with the mathy symbols. You have to put some kind of phrase at the beginning. But since this is relatively elementary, the author made the choice to say it is obvious. Okay. The set 1, 2, 7 is a subset of the set 1, 2, 3, 6, 7, 9 because everything in the set on the left is also in the set on the right. Compare that with this second statement. The set 1, 2, 7 is not a subset of 1, 2, 3, 6, 8, 9 because we don't have everything in the left contained in the right set. Okay. So something like the set 1, 2, 3 is a subset of the natural numbers, or the set of real numbers x such that x squared equals 1 is a subset of z. These are both true statements. So think about why those would be true. And go ahead and pause to take a moment to decide whether or not the following two statements are true or false. Notice the first one is actually an and statement, which means both of these would have to be true in order for the whole thing to be true. And then think about what we have here in part B. So take a moment to try that and then come back. Okay. So hopefully you had a chance to try that one. One quick comment as we get ready for the next video. It's really important to assume, and we've kind of said this already, it's really important that we don't assume if A is not a subset of B that automatically B has to be a subset of A. We're going to explore that in more detail in the next part. But quick example, if set A is 1, 5, 7 and set B is 3, 8. We know that A is not a subset of B, but we also know that nothing in B is in A, so we cannot say that B is a subset of A. In other words, B is not a subset of A.